Hi guys, welcome to this video lesson. In this video, you are going to learn the Fischer esterification reaction. This is the most important reaction in organic chemistry. Today, I will discuss the history, reaction, mechanism, application, and the limitation of this reaction. Okay, now let's look at the historical background of this reaction. This reaction was discovered by Hermann Emil Fischer and Arthur Speer in 1895. Emil Fischer was a German chemist who developed the Fischer projection formula and the lock and key model of enzyme action. Also, he discovered the phenyl hydrazine, ozone, and the organic synthesis of D-glucose. In 1902, he was awarded Nobel Prize in Chemistry. Now let's have a discussion on this reaction. This reaction involves the treatment of carboxylic acid and an alcohol in presence of an acid catalyst to give an ester. Here, this is the main reaction, and we see that the reactant molecules are normally the carboxylic acid and the primary or secondary alcohol, and the product molecules is an ester. This reaction is a type of coupling reaction in organic chemistry. Now, the most important part of this video, that is the mechanism of this reaction. Mechanism of this reaction involves the following steps, that is the proton transfer, the nucleophilic attack, and once again proton transfer, losses of water, and deprotonation. Now here I will discuss all of the steps in details. Firstly, the carbonyl oxygen of this carboxylic acid picks up a proton from the acid molecule and gains a partial positive charge and thus increases its electrophilicity. Now this carbonyl carbon is attacked by the nucleophilic oxygen of this alcohol molecule and forms a new carbon-oxygen bond. Now this intermediate loses a proton and is converted to this compound. Then this compound picks up a proton from the acid catalyst and is converted to this intermediate. Now one molecule of water is eliminated from this intermediate and is converted to this intermediate. And finally, this intermediate involves the deprotonation and is converted to the final ester product. Now, let's see the application of this reaction. This reaction has many applications. Among them, some important points are mentioned here. Product of this reaction has a wide range of synthetic and biological applications. For example, esters are used as solvent for lacquers, paint, and varnishes. Though it has many applications, it is involved with some limitation. There, the primary disadvantages are its thermodynamic reversibility and relatively slow reaction rate. In a closed vessel, it is more difficult to remove the water molecule to drive the reaction to complete. It is not the optimal way of making the phenolic esters. Tertiary alcohols undergo a fast dehydration in presence of strong acids. Well, that's all from me. Thanks a lot for watching this video lesson. If you like this video, please press the bell icon and subscribe my channel. If you have any question, please write it in the comment box and I will try to get back to you. See you